Hello, we're going to do tangents of circles examples. I'm going to go ahead and apologize now because you may hear my dogs playing in the background. They may get a little loud. So, tangents of circles, if you go to the notes in the video, you're going to have our vocabulary for our different types of segments, points, and lines. We also have different types of circles, concentric and tangent circles. We have a couple of theorems. Two of them deal with tangents and perpendicular, and the other one deals with tangent segments. Okay, so we're going to start with our matching the line or the segment with the correct vocabulary term. So if we'll pull up our notes and look, the first one that we have here is a chord. And if we go to our notes and we look and we see that a chord is a segment who has both endpoints on the circle. So if I look at points A and B on the circle, so a segment that connects them would be a chord. We have point D and E on the circle. So the segment that connects D and E would be a chord. We also have point E connected to point G, which is on the circle. So the segment EG is also a chord. Our next one that we have is a secant. And if we look over here, a secant is a line that intersects the circle in 2 points. So this one has to be one of our two lines. So if we look at the line that is an extension of our chord, we have the line that goes through D and E. So our line that goes from DE is a secant. A tangent is our next one. So if we look at our notes, a tangent is a line that intersects our circle at exactly 1 point. So this one is also a line, but it only touches our circle at 1 point. And our line in the diagram that touches the circle once is the line FG. Our next one is the diameter. And our diameter, if we go and look, is the distance across the circle through the center, and it is a chord that passes through. So this one has to be a chord, but it also has to go through the center. If I can spell that right. This one is a chord that goes through the center. So when we look at our chords and we find the center, our chord that we labeled earlier that also goes through the center happens to be number 4, the segment DE. So DE is a chord, and it is also the diameter. And last, we have the radius, and it goes from the center to a point on the circle. So if we look, the radius is the distance from the center to a point on the circle. So it has an endpoint at the center. So our center of the circle is at C. So we look, our 3 remaining segments all have an endpoint at C, and the other endpoint is on the circle. So each of these is a radius. In the next problem, we are working with theorem 10.2. So in a plane, if a line is perpendicular to the radius of a circle at its endpoint on the circle, then we get that it's a tangent. So when we look at our picture, our 5 is the radius. We're trying to see if AB is the tangent. And the way we're going to do this is we actually use the converse Pythagorean theorem to see if we have a right triangle. So if a squared plus b squared equals c squared, we get a right triangle. This means that we would have a right angle, which means that we would be perpendicular. So if we let our radius be a, our tangent is the b, and then this center to our exterior point of the tangent is c. You have to be careful because occasionally they will give you this in two pieces that you'll have to add together. So we're going to test 5 squared plus 14 squared and compare it to 15 squared. So 5 squared plus 14 squared is 221. 15 squared is 225. So since these are not equal, we do not have a right triangle, which means we do not have a right angle, which means that it is not perpendicular. So this is not tangent. The next one, we're going to use our definition of a tangent line. It's a line that intersects a circle at exactly one point. And we're going to deal with common tangents between the two circles. There's two different sets of common tangents. We're going to have the ones that are between the two circles. These are known as common internal tangents. And in this particular problem, I can draw a vertical line between the two circles. If we have a vertical line, remember from Algebra 1 that vertical lines have an equation of x equals the x coordinate. So 1, 2, 3, 4. External tangents are on the outside of our circles. So it's going to set across the outer edge of both circles. So there's one at the top. And then for this particular set, there's a second one at the bottom. So this time we have two different external tangents. These are horizontal lines. So remember from Algebra 1 that a horizontal line has the equation of y equals the y coordinate. So the one at the top, we're at 1, 2, 3, 4, and the one at the bottom is at 0. Our last example, we're going to work with theorem 1013. And in this theorem, if we have two segments that have the same exterior point and they are tangent to the circle, then they are going to be congruent. Remember, congruent means that they are equal lengths. So for each of these problems, our two segments that are tangents are of equal length. So we have two equal length segments. So for each one, we're going to write an equation setting the two measurements equal. So in problem 11, x squared minus 1 has to equal 24. In problem 12, the 4x has to equal 2x plus 8. In problem 13, the 7x plus 4 has to equal 3x plus 68. And then now we just go through and solve to find our value of x. So in problem 11, we remove minus 1 by adding. X squared is 25. Remove the square by doing the square root. And since we're dealing in measurements, we only need the positive square root, which is 5. Problem 12, we're going to subtract 2x to get all of the x's on the same side. So 2x equals 8. Divide by 2 to remove the multiplication. And x is equal to 4. And in problem 13, we're going to subtract 3x to get all of the x's on one side, and subtract 4 to get the constants all together on one side. So we're going to get 4x equals 64. When we divide by 4, x is going to equal 16. Watch this as many times as you need to. Pause if you need to, but you should have practice problems and examples that you can use. Look at these for your exit slips as well.